Good day everyone, I would like to introduce you to a project that's looking at the development of fungicide resistance of Monilinia and Botrytis populations from stone fruit orchards where pyrimethanil and or fludioxonil has been applied. The main reason for starting this project is the concern related to development of fungicide resistance against fludioxonil. We know fludioxonil works very well. It's applied post-harvestly and can control numerous post-harvest pathogens. So when we see this post-harvest fungicide moving towards a pre-harvest environment, we start to get concerned if there will be an increase in resistance in post-harvest pathogen populations, and therefore compromising our storage life of our stone fruit. A good example is where fludioxonil was applied in raspberry fields for roughly 5 years, and this resulted in a resistance frequency increasing from 6% to 90%, and this really highlighting the risk if a fungicide like this is applied pre-harvestly. So based on this, we have our aim where we want to see how the stone fruit industry is currently looking, and seeing how if we're seeing fungicide resistance in orchards where pyrimethanil and or fludioxonil has been applied for multiple years, and of course comparing that to pathogen populations isolated from orchards where these active ingredients have not been applied yet. The main focus will be Botrytis and Monilinia. Looking at our materials and methods, first, Louw, based on our collaboration, we identified orchards where we see the application of fludioxonil for multiple years, 2 or 3 years, or the application of pyrimethanil for 2 to 3 years or more, and then of course orchards where we haven't seen the application of any of these two active ingredients, and then visiting those sites, taking symptomatic samples or symptomatic fruit from those sites directly, taking those samples to the lab and making isolates onto PDA plates. And after seeing sufficient growth, we could group or class these isolates and select our Botrytis and Monilinia cultures and isolates, and hopefully based on how much we get, hopefully we get enough per specific background description, we could do our in vitro study where we would plate these isolates onto PDA plates amended with the fungicides of interest. This results will then be used to select our isolates or based on our resistance background, if it's moderate or high or not resistant at all. These isolates can then be used in vivo studies where they will be inoculated into fruit and then treated with the fungicides of interest. So we have visited sites, roughly 5 orchards. We have made isolates from samples, and we have looked at different methods to look at fungicide resistance, but we still need to screen some of the isolates we obtained from the orchards, and then move on from there. So basically, from those isolates we made from symptomatic fruit, we got roughly a total of over 300. We made roughly over 300 cultures. Unfortunately, a lot of them were fungi that were not of any interest. We only got roughly 36 Monilinia isolates and 23 Botrytis isolates, and the majority of them coming from one orchard background. So in short, we need to visit more sites and collect more isolates in the coming season, and then cluster or group all our isolates of interest based on the orchard background, so we can start with our in vitro fungicide resistant tests. This is photos we took while visiting our sites. The one site specifically had good indication of Monilinia, and in some cases Botrytis on the fruit. Big concern was, although, that we saw rhizopus and mucor rots on the fruit. These two fungi are big contaminators when we try to isolate or make cultures, because they grow quite quickly and overgrow the pathogens we are looking for. So here we have 2 methods to test fungicide resistance. On the left is the less well-known disc diffusion method that worked quite well, but it is a lengthy process to follow through. On the right, you have your fungicide amended method. The fungicide is placed into the agar, and then the cultures are then placed right in the middle of those plates, and based on the amount of growth, the cultures are classed as being sensitive or resistant. You might not necessarily see it here, but the UTC plates are fully overgrown with mycelia compared to the treated plates that's only shown growth right in the middle. Thank you to everybody that helped to identify the orchids and making this project possible.